let's talk about modeling with the inverse of a linear function. In a model for a real-world situation, the variables have specific real-world meanings. For example, d equals 60t can be used to represent the distance d in miles traveled in time t in hours at a constant rate of 60 miles per hour. Written in function notation, we do not change our variables. Okay, so in this case, we know that distance depends on time. So d's of t would be equal to 60t. And you can see our function is exactly the same as the original, d equals 60t. Function notation means we just changed it into distance depending on time. So d's of t. To find its inverse, we solve for t, okay? Here is the difference. When we found inverse functions in the previous section, we would take our variables and we would flip-flop them, right? We would switch x and y and then solve for y. In a real-world application problem, that cannot be done because distance is specific to the variable d and time is specific to the variable d. So our workaround would be to leave the function as it was, d equals 60t, and we are simply solving for the variable that is not already solved. In this case, d has been solved for. The inverse function means we would solve for t, or time. So how do we solve for t? We would divide by 60, and that gives us t equals d over 60. Okay, now we are going to rewrite this once again into function notation. So if the original function was distance according to time, the inverse function is time depending on distance, equal to d over 60. Okay, so this represents the time as a function of distance. Because the meanings of the variables cannot be switched, we do not interchange them as we do with x and y. In fact, we may even need to restrict the domain and range for the inverse to make sense with the situation. So if you look at example 2 here, it says for the given function, state the domain and the domain of the inverse using set notation. Then find an equation for the inverse function and graph it. Interpret the meaning of the inverse function. So A says the equation C equals 3.5G gives the cost C in dollars as a function of the number of gallons of gasoline G when the price is $3.50 per gallon. State the domain and range of the original function. Okay, so the original function, you can see C equals 3.5 grams. This is telling us that cost is dependent on the gallons. Okay, so when we think about dependent and independent variables, we know we're talking about domain and range. Okay, domain being our independent variable, in this case, would be G. So for the domain, G is, well, let's talk about what G is. When you think about gallons, right, that means we are fueling, we're putting gasoline into a car or truck or whatever, any type of vehicle, right? We would start counting at 0. Can you put negative amount of gasoline? Of course not. So our inequality would be G is greater than or equal to 0. Okay? For the range, for the cost, okay, think about this. If we are starting at 0 gallons of gasoline, then the cost of 0 gallons of gasoline would also be 0, right? So cost would be greater than or equal to 0. Then the domain and range of the inverse function. Well, this should be easy, right? All that means is that we flip our variables. So the domain would be cost. Cost is greater than or equal to 0. And the range would now be the gallons of gasoline put into the vehicle. Find the inverse equation. So we're going to copy down our original equation. C equals 3.5G. and we are going to solve for g. So we divide by 3.5, and we have g equals c over 3.5. Okay, this is our inverse function. Now, here's the deal. You cannot have a decimal in a fraction. Okay, so in order to not have a decimal in a fraction, you are going to divide. 1 divided by 3.5. Okay, and if you put that into your calculator, 1 divided by 3.5, you get a decimal of 0.2857. However, what I want you to do is convert that into a fraction. How do you do that? If you have a graphing calculator, you are going to press the math button over on the left side. You guys see you have second alpha math. So press math and it'll bring up a menu of options. Number 1 has a little arrow and then it says frac, right? F-R-A-C. What that means is convert to a fraction. So if you press enter, your calculator should now say answer to the little arrow or triangle, fraction. Press enter and you can see that your fraction, 1 divided by 3.5, is now equal to 2 over 7. So our inverse function is g equals 2 over 7c. Okay, now to graph it, you can see it's already graphed, right? But what we would do is we would create a table of values and substitute for the inverse function. Okay, we're graphing the inverse, not the original. So if I substitute 0, I'm at 0. If I substitute 1, I am at 2/7. Okay, 2/7 gallon. If I substitute 2, I'm at 4/7 of a gallon, and so on and so forth. Okay, that is how you would graph the inverse. Let's do one more. For B, it says a car's gas tank, which can hold 14 gallons of gas, that sounds like important information, contains 4 gallons when the driver stops at a gas station to fill the tank. The gas pump dispenses gas at a rate of 5 gallons per minute. The equation G equals 5T plus 4 gives the number of gallons of gasoline G in the tank as a function of time T in minutes. All right, so let's think about this. When we think about our function, here is the original function. G equals 5T plus 4, okay? We know that the dependent variable is G, or the gallons in gasoline, and the independent variable is T, or time, okay? So what we would do is we would write it out as the domain is time, and thinking about time, we're really not limited to time, right? It could take however much time it needs. And the range would be G for gallons. Now, when you think about the range here, you are told that the car only holds 14 gallons, but it already has 4 gallons. So we're not going from 0 to 14, we're going from 4 up to 14. Right? The car already has 4 gallons, so anything you pour will be between 4 and 14. Okay, so inverse function. Let's find the inverse function. In order to find the inverse function, we are going to solve for t, which means we are going to subtract 4, and then we are going to divide by 5. Okay, so my inverse function is t equals 1/5 g minus 4/5. This is the inverse function. Okay, this is what we want. The domain becomes the gallons, so G, 4 to 14, and the range becomes time. Okay, now here's what I want you to consider. Originally, for the original function, we said that time had no restrictions. And that was true because we could fill up, it depends on the rate of the fill, right, to fill up the tank. In this case, you are told that it fills up at 5 gallons per minute. So we have to find a restriction here because if the car can only take 14 gallons, we need to figure out how much time it will take to fill up the 14 gallons. Well, how do we find that answer? We plug it in, okay? So if we plug it in, T equals 1/5 times 14 minus 4/5, okay? Plug it in. 1/5 times 14 is 14/5 minus 4/5. And we get time equals 10/5, which is 2. This is telling us that it's going to take 2 minutes to fill up 14 gallons. So when we start filling up, we're at 4 gallons. We know that's times 0, right? 4 gallons times 0, that's what's already in the car. When we get to 14 gallons, it's going to take 2 minutes. So we have our coordinate points here that we will use to graph 4, 0, and 14, 2. Okay, so let's go ahead and graph our function. 4, 0, this is what the car starts off with. And once it reaches 14 gallons, a time of 2 minutes has passed. Connect those points. And in this case, you want to start at the point, end at the point, right? It's not an extended function. It does not continue forever. It has a start and an end. This here would be the graph of the function, of the inverse function, okay? T equals 1/5 G minus 4/5. All right, go ahead and hit pause, try C, come back when you are done. All right, this is what you should have for C. First of all, here is our original equation, W equals 600 minus 20T. The domain, time is unlimited, so time is just greater than 0, right? We can't have negative time. Now the range would go from 0 to 600, right? Water, we're talking about 600,000 gallons and we're draining it. Now, I know inversely we would think, well, we would go from 600,000 gallons down to 0. Yes, that is correct. But remember, range is always read from bottom to top, so smallest to biggest, 0 to 600,000. And again, I know it's 600,000. I use 600 because my graph is listed in thousands. Always go by your graph values if they are already given to you. The inverse function, solving for T, would be negative 1/20W plus 30. The domain is now the water in gallons, right? 0 to 600,000. And the time, which is our range, has to have a restriction. Now, when you substituted 600, you should have gotten 0, right? Because it is being drained. And when you substituted 0 for gallons, you should have gotten 30. Okay, so this one is a little inverse, and again, it is because it is being drained. All right, so looking at our graph, when we have 600,000 gallons, we are at 0. Remember, it is being drained. When we are at 0 gallons, it has taken 30 minutes to be drained. And I know this looks weird. Again, this is because it is an inverse function. It is a negative slope. We are draining the pool, we are taking out water, but our function is inverse, which means time is dependent on the amount of water there is. Last portion of the notes is to determine if the function has an inverse graphically. So in order for a function to have an inverse, it must be a 1-to-1. If we want to determine whether a function has an inverse just by looking at its graph, we can use the horizontal line test. Now, if you recall from previous years, when we've looked at functions, we have used the vertical line test, which is where we would take a pencil, right, and run it through the graph vertically, vertical line test, and as long as our function only touches each of these segments at one point, it passes the vertical line test, meaning it is a function. In order to determine if each function below has an inverse, we would use the horizontal line test. So what we can do is run it through horizontally, and you can see at this point, my function only touches that horizontal line once, so we would say yes. But once we continue downwards, our function is now touching that horizontal line at 2 different points, and it will continue for the remainder of the function as we go down. So in this case, this function, right, the inverse would not be a function. So inverse is not a function because it fails the horizontal line test. Now, if we look at B and we perform the horizontal line test, right? Actually, let me go back. If I perform the vertical line test, I know that this is a function because it passes the vertical line test. If I conduct the horizontal line test, you can see that my function only touches each of those lines at one point. So in this case, yes, the inverse is a function. I'm just going to initial this is a function. Okay. All right. Now you guys go ahead and try C and D. Hit pause really quick and determine, is the inverse a function? Yes or no? All right, that should have been quick and easy. So as you can see, this function here would cross my horizontal lines 3 times. So in this case, the inverse would not be a function. For D, my function would cross my horizontal lines at 2 points at any given time, so it is not a function.